Hi everyone. My name is Eve. My group is composed by 5 members, which are Andy, Daniel, Isashar, and Tara. So for this semester, we decided to do a fingerprint door lock using Arduino. For this presentation, we will go through the main idea. We will talk about the sensor determination, data collection, communication methods, data analytics, the feedback that was generated, as well as future work and conclusion. So as we all know, Arduino is an open source electronics platform that was built on simple hardware and software. And this presentation, explains how we use the Arduino board to build a fingerprint door lock.
Due to the lock itself only requiring a fingerprint as an input, an optical sensor was determined to be the best sensor for the project. Another little factor that went into using this specific model is the fact that it's compatible with an Arduino breadboard, which allows us to actually use it for the project. The data collected for this project will simply be photos that were created by users applying their fingerprint on the fingerprint lock in order to make such prints valid passwords. The photos will act as an input for the lock with only fingerprints that match an already existing photo, allowing the lock to be unengaged. Such photos will be stored on a local database within the Arduino board and retrieved to compare with the user attempting to use the fingerprint lock. The data collected will be stored on an external database would be ideal in case the local databases are started or lost, as well as providing more security. But within the scope of this project, only a local database will be used as it satisfies the project's needs and goals, as well as being much simpler to implement and modify.
Okay, so for the communication methods, this project uses an Arduino Uno microcontroller, an Adafruit fingerprint sensor, and a servo motor. The primary communication method is serial communication between the fingerprint sensor and the Arduino Uno. Another communication method is the USB or the wire communication between the Arduino Uno and a computer for debugging and testing. For communication implementation, the next step in the communication implementation is programming the Arduino Uno microcontroller. The microcontroller is programmed using the Arduino Integrated Development, the IDE environment. The code used in the project involves setting up serial communication between the Adafruit fingerprint sensor and the Arduino Uno, as well as controlling the servo motor using the PWM. The code also includes logic for comparing the fingerprint data received from the sensor to a database of stored fingerprints and unlocking the door if a match is found. Once the code is written, the next step in the communication implementation is uploading it to the Arduino Uno microcontroller. This involves connecting the Arduino Uno to a computer using a USB cable and selecting the correct board and serial port in the Arduino IDE. The code is then compiled and uploaded to the microcontroller using the IDE's upload button. After the code is uploaded, the communication implementation enters the operational phase. The project also uses UART for communication between the Arduino Uno and a computer. This allows for easy debugging and monitoring of the project's performance. The Arduino Uno is connected to the computer using a USB cable, and data is then transferred between the two devices using the UART. Okay, so for the data analytics, this project uses the Adafruit fingerprint sensor to capture and store the fingerprint data, which is then compared to a database of stored fingerprints to determine whether to unlock the door. The Adafruit fingerprint sensor continuously sends binary data to the Arduino Uno via serial communication, which the microcontroller processes and uses to determine if the fingerprint matches any of the stored fingerprints in the database. The first step in the data analytics process is capturing and storing the fingerprint data. The Adafruit fingerprint sensor is capable of capturing high-resolution fingerprint images, which is then processed to extract the unique features of each fingerprint. These features are then converted into a digital format and stored in the microcontroller's memory. The fingerprint data is also encrypted for added security. The next step in the data analytics process is comparing the captured fingerprint data to the stored database of fingerprints. The microcontroller uses algorithms to analyze the captured fingerprint data and compare it to the stored database of fingerprints. This involves comparing the unique features of the captured fingerprint with the features of each fingerprint in the database. If a match is found, the door is unlocked. The system can detect and log unauthorized access attempts, allowing the user to monitor and track any attempts to gain access to the locked area. The data collected by the system can also be used to identify and prevent potential security breaches, such as any attempts to bypass the fingerprint recognition system. By capturing and storing fingerprint data, analyzing the data to compare it to the database of stored fingerprints, and continuously monitoring and improving the system's accuracy and security, the project provides a reliable and effective solution to the problem of security.
This is the Adruino fingerprint door lock. What I'm about to do, run the code. It's gonna read my fingerprint. I'm gonna save the fingerprint on first, and it's gonna send a signal out to the motor, and then it's gonna unlock and unlock. So right here on the screen, what I'm gonna do, I'm gonna run the code so it reads my fingerprint and saves it. I'll go to serial monitor. Right here it's asking me what ID I want to save the fingerprint as. Let's go with 3. Now it's gonna read my fingerprint, so here we go. Let's read it again. Okay, now right here on the screen, you can see it asks for me to put my finger right here and fingerprint again. Fingerprint stored. Now I'm gonna go right here, and this is gonna be to lock and unlock the door with my fingerprint. So I'm gonna run it. And then, as you see right here, it's waiting for a finger. So now, I'm gonna run the finger. And it's starting to turn. It's going to open, and it's going to stay open for about 5 seconds, and then it's going to close. This is simulating you coming in from home, opening, unlocking the door, coming in, and then it's gonna lock on itself. And there we go. That is the fingerprint door lock. The feedback generator right here, what happens first, it's asking for the user to enter their fingerprint. Once the fingerprint is located, it checks if it's able to open it. Once it does that, it goes ahead and opens the lock, and then it closes after that. Then after that, it shows that it's waiting for another fingerprint, so that way it could open and close again.
Future work with such technology can be in security and privacy are crucial in the advanced technology era. Biometric authentication is a useful tool for individuals to protect themselves and their loved ones. Future work includes using biometrics as a passport. The passport method has been used by major companies such as Apple for sensitive materials. For example, when someone unlocks their phone using Face ID or unlocks their MacBook using the fingerprint touch. Other companies have followed suit and use biometrics for validation purposes. In conclusion, fingerprint authentication using Arduino code is effective for securing access to system and devices. Many phones, laptops, and safes already use this form of biometric authentication. The fingerprint authentication is reliable and secure with many potential applications and offers a cost-effective and customizable solution for securing access to devices and systems. Thank you so much for watching, and we hope you guys enjoyed it.